Hello everyone. Today we're going to go ahead and do some practice problems to review for our Unit 5 exam. So I'm going to go ahead and hide my tabs, but what I want you to do is go ahead and sketch, find me the solution to the arctangent of -1/2. So what is the angle that creates this ratio of -1/2? So hopefully you have your notes just like I do here next to me. So on the right hand side, these are the notes. Okay, so give it a try. Okay, so hopefully you were able to get started. When we look at this like arc sine, what I want you to know is that this is restricted to the interval that's saying that it is restricted to quadrant 1 and quadrant 4. Quadrant 1 is right here and quadrant 4 is right here. And in quadrant 1 it is positive. In quadrant 4 arctangent is negative. Okay, and that's pretty much relating to the range. So from -90 degrees to 90 degrees. So in this scenario, I have that my sine is negative. So according to this, I should be drawing my angle in quadrant 4. For some reason, it's not letting me. In quadrant 4, so according to our trig bow tie, remember our triangles need to be looking like this, making 90 degrees at the intersection with the x-axis. So something like this. Just like that. So we should have this right here, since we had our sine being negative, and we have a triangle right over here. My theta is the closest to the origin, and this right here is my right angle. Okay, so now what do I do? Well, I need to go ahead and label everything that I know. So I know the one in the horizontal is my adjacent side, my opposite is right here, and my hypotenuse is the one projected by the 90 degrees. So according to this, I have sine, and that is opposite over my hypotenuse. Okay, now we have a negative right here. Recall that the only side that can be negative is the opposite. The hypotenuse is never negative. The hypotenuse is never negative. And that, you can think about it like this. When I do my Pythagorean theorem to find the hypotenuse, you can see that everything has been squared. So therefore, there's no way I can have a negative in that scenario. So we have that the opposite side would be my -1. And that makes sense. Right here below is a -1. And my hypotenuse is 2. This right here is in the unit circle. So I can go ahead and see that my adjacent side would be square root of 3. Okay. So we can go ahead and solve for this by saying, sorry, it's not working. By saying what theta gives me this -1. Well, I know that in my 30, 60, 90 triangle, theta, when theta is 30 degrees, it gives me 1. In other words, pi over 6. So I want you to know that is a reference angle. So this right here is pi over 6. But keep in mind, keep in mind that it goes in this direction, so it is negative. My solution is negative pi over 6. Awesome. And I have a full video that dedicates just to talking about how to find the evaluating arc sines and cosines and tangents. Okay, let's go ahead and step it up a notch with our composition of inverse trigs. So friendly reminder, this right here, go ahead and do the first one, what's in the inside first, just like we did the last example. So go ahead and pause it and give it a try. So we have arc sines, so we're still working with this one right here. So we're going to have to draw a triangle that's going to be associated to arc sine. We can see that this is positive, so therefore it's only in quadrant 1. So I'm going to go ahead and draw my triangle right over here. And I have that sine is my opposite side divided by my hypotenuse. So this is a 2, and my hypotenuse is a 6. Okay. Keep in mind, we are working with a right triangle, so therefore to find the missing side, in this case my adjacent, I should be able to do it with the Pythagorean theorem. So I should say, let's go ahead and let's say a squared plus b squared equals c squared. So a squared, in this case, as long as it's one of the legs, is 2 squared. My adjacent side squared is equal to my hypotenuse, which is the longest side, in this case, 6 squared. Okay, so we have 4 plus b squared is equal to 36. If I go ahead and subtract 4 on both sides, I can see that b squared is equal to 32. And to solve for b, I go ahead and square root both sides. So b is equal to the square root of 32. That is my adjacent side. Awesome possum. So we're thinking, okay, what angle creates the 2? Well, I really don't know that, since this is most likely outside of the unit circle, especially when you see that this radius right here would be 6, and that would not happen. Okay, so what we're going to go ahead and do is say, okay, I got this theta that gives me the 2, so I'm going to say cosine of this theta, which is this triangle right here, is going to be my adjacent side divided by my hypotenuse. So this adjacent side is square root of 32 divided by 6. Okay, that would be my cosine. Keep in mind, they could ask you the reciprocal of cosine. So let's say if they asked you secant of theta, that is 1 divided by the cosine of theta. In other words, saying the hypotenuse divided by the adjacent side. In that case, it would have been 6 divided by square root of 32. And we know that we can have this square root in the bottom, so we need to rationalize by multiplying by square root of 32 on both sides, numerator and denominator, and that is equal to 6 square root of 32 divided by 32 for secant of theta. Awesome. Okay. Alrighty, go ahead and try this next one. Keep in mind that they are saying the angle of elevation to the top of the bookshelf is 60 degrees, and we are given a point. That same point is 10 feet away. Okay, so let's go ahead and fill this in. So the angle of elevation, guys, that is from you looking up at something. So that is the theta from the ground looking up at something. Okay, so in this case, it is 60 degrees, right? Because I'm looking at the top, right? The top of the bookshelf from the bottom, right? They want us to find the height, right? What is this height of this bookshelf? So I'm gonna go ahead and call it X. And I know the distance right here from the bookshelf to the point that I originally saw is 10. So let's go ahead and think of what we have. And again, my pen is not working. What is going on? I have a missing side, which I'm going to go ahead and call it X, right? Which in this case, I can see that from this theta, it is my opposite side. I have this 10 right here, which I know is my adjacent side. And I have a theta, which we know is 60, right? 60 degrees. Okay, so I want you to think about your sine, your cosine, and your tangent. Which one of these has a theta and is a ratio that has opposite and adjacent? So hopefully that is TOA. That is tangent of my angle, which they gave me 60, is equal to my opposite, which is X, divided by my adjacent side, which is 10. I go ahead and solve for this, so it's going to be 10 tangent of 60 degrees is equal to X. Okay, you can go ahead and put in your calculator. It gives you like 17.32 or something like that. Or as we noticed in class, a tangent of 60, that is the proportion of the 30, 60, 90 triangle. 60 square root of 3 over 1. So this is 10 times square root of 3. Is the same thing as approximately 17.32. Don't forget your units, feet. Okay, awesome. Alrighty, one last one is graphing inverse trig functions. So keep in mind, I won't take a lot of points if it's not exactly to scale. That's perfectly fine. Ideally, I would have given you the graphing paper, but I know a lot of us like to do it on a regular notebook. But ideally, what I really do care about is the domains and ranges, right? The new domain and range. So keep in mind, I went ahead and showed you this in the lesson of Dr. Dabsey, where this is the vertical shift. This is the vertical stretch or compression. This right here is horizontal compression or stretch. And this right here is horizontal shift and yeah, shift. Okay. So what I want you to know is that for this arc cosine, and I believe I did this one already on our notes, but for this one, go ahead and find out what is the domain. You know what? Let's make this a little more fun if I change to arc sine, because I think I did this one already. No, if not, it's fine. Okay. So we have this right here, the domain of arc cosine. The domain is from -1 to 1. Okay. The range is from 0 to pi. So these are the original ones. However, this function is going through some transformation, so it's going to go ahead and be applied these right here. These. So remember, Dr. Dapsey is rad. Okay. So in this scenario, I'm going to go ahead and multiply my domain by the reciprocal of my compression, right? So instead of it being multiplied by 1/2, now it's getting multiplied by 2. And it's going to go ahead and be the opposite of this right here, the 4. So it's going to be +4. This right here is going to go ahead and help me find my transformation. Okay. The next one, so we got 0 and pi. So we're going to go ahead and do the same thing. We're going to go ahead and multiply by my amplitude, which in this case is 3. And I'm going to go ahead and add my vertical shift, which is pi. So let's go ahead and do that real quick. It's not letting me. Okay, so let's go ahead and find our new domain. New domain. Well, I got the same pen. So we have -1 and 1, and I'm going to distribute a 2 into both parts. So now I have -2 and 2, and it's telling me that I'm going to go ahead and add the 4 units to the right. So everything shifts to the right. So it's going to be 2 to 6. This is my new domain. 2 to 6. Okay. My new range can be found doing this right here. So it's going to be 0 to pi, and I multiply by 3. So it's going to be 0, 3 pi plus pi. So it's going to be 0, 4 pi. This right here, whoops, this right here is pi. Sorry, 0 plus pi is pi. Okay. And then 3 pi plus pi is 4 pi. Okay, so this is a new range. Okay, so now all I have to do is sketch it out. No idea why my pen's not working. Okay, so the domain, the farthest left I can go is 2, and the farthest right I can go is 6. Okay, then I have my range. The lowest I can go is pi, and the highest I can go is 4 pi. So I'm going to go ahead and do a little square right here to go ahead and represent my new function. Okay, so last but not least, I'm going to go ahead and see, okay, well, I have all of this. Now what do I do? Well, we're going to go ahead and mimic what we know of cosine, which is this one right here. It starts in the farthest right, then it goes to the middle, and we'll find that middle right now, and it goes to the left. And it does this cubic function looking like, but except that it does not continue to infinities like arctangent does, or like how a cubic does. Okay, last but not least, guys, how do we find these points right here in the middle? So keep in mind, we go ahead and add them together. So 6 plus 2, that is 8, divided by 2 is 4. So this right here is a 4. And then pi plus 4 pi is 5 pi. Okay, awesome. So this point right here would be our 4 pi. So now we have the new range, we have the new domain, we even have our point, and we can see this new transformation from this right here. So hopefully you enjoyed this review. I did go ahead and attach more practice problems in Teams, and hopefully you guys give them a look. And those are a little bit more challenging, but with your notes, I'm pretty sure you can go ahead and get them done. Okay, as always, guys, I hope this helps, and please reach out to me if you need any more assistance. All right, thank you. Bye.